Good morning. So today what we are going to see over here, Adina, what about the fixed point arithmetic and floating point arithmetic? Actually, we'll have two different types. One to be the fixed point, another one to be the floating point. So in the case of a fixed point, actually the array indices that is about an loop dynamic uh, range. Okay, and apart from that, we'll have a fun. Um, Whereas in the case of an floating point, we'll have a fun wider counters, etc. Whereas in the case of an, so it will be having a fun free users, this is from scaling concerns. And apart from that, they will be having around over here less sensitive to an error accumulation server. Whereas in the case of some fixed point, we'll have a fund overflow or an underflow the same. In case of fund, we'll have around a 50 percentage slower for the same also over on it. So we'll have a fund management technology. Whereas the case of an error budget, we'll have a fund higher cost, which shows that the implementation will also be an the hardware architecture to be given over here on the case of an. So in the case of an fixed point representation, the point of the binary value to be a fixed one, whereas in the case of an negative number, we'll have of an three different representation way. We'll have of an sign magnitude, one's complement format, and then we'll have of an two's complement format, and then we'll have of an three's complement over on it. Okay. So whereas in the case of an, what are about the applications of an PDSP? So we'll have of an image processing, speech processing, and then digital cell phones, noise cancellation, wireless communication, satellite communication, video conference, etc. over there. Whereas in the case of an normalized, it is after to be an summations over there. Okay. Mantisa, which is to actually to be round over there. Uh, and then the fixed point, which does not always have a limit performance. So example, for dynamic range, which is using often 50 to 60 decibels, the thing is to be that uh, we'll have often 12-bit quantization, which is more than adequate. So for hi-fi audio with 80 dB dynamic range, so we'll have a 16 bits, which are more than the adequate value. Okay, how we all know that how the DSP process differ from the other process. Actually, the special purpose processes which are designed with switches which are required for DSP processing applications, such as we'll have often multiplier and accumulator, modified bus structures, multiple access memory, multiport memory, and we'll have often pipelining. But the conventional microprocessor, which does not have these processes over here. And whereas the case of an advantages of DSP processors are to be the low power requirement, low cost, real-time input or output capability, and availability of an chip memories over on it. Okay. What about the overflow management, the shift and the unbiased rounding? So we'll have a left shift which removes redundant sign bit after two complement multiplication. Similarly, when you are making a right shift, downscales numbers as word growth is detected. Whereas the case of an unbiased rounding, it prevents accumulation of a small DC bias from outputs which fall just half away between adjacent rounded values over on it. Whereas in the case of an saturation logic, it sets the content registers to maximize the value of overflow. Whereas the case of a block floating point will have a scaling logic plus exponent registers. If overflow conditions of any scale point is detected, then what will happen now? The entire array is rescaled downwards and the scaling is started in the block exponent registers. Okay. So we can use some examples for fixed point and floating point process. So what we have over on it, this Texas instruments we'll be using for the case of an fixed point, that is TMS 320 C5X, whereas in the case of an Motorola, we'll be using of an ASP 563X. Whereas for the floating point process, we'll have a Texas Instruments TMS 320 C54X, TMS 320 C67 double X over on it. And we are need to know what is pipelining. So pipelining is a technique which is used in which the processor begins executing a second instruction before the first which has been completed over on it. That is several instructions which are in the pipeline simultaneously, each at a different processing stage. The different stages in pipelining are fetch phase, decode phase, memory read phase, and execute phase. And what is pipeline depth and what is its value of the DMS 320 C54X? Actually, the number of instructions that are processed simultaneously in the CPU is referred as a pipeline depth. The pipeline depth of TMS 320 C54X is around 6, whereas in the case of an C5X, it's to be the 4 over on it. So this is the case what we'll be seeing over here. And what about we'll be having of an scales over here. So when you are saying about an shifters, actually the scales numbers which is to prevent underflow or an overflow over here. So it is the conversion between the fixed point and the floating point. The many bits must be shifted in a single cycle in order to preserve single cycle computation speed. There is a barrier shifter. We'll have a logical shift assumes unsigned data and fills with zeros left or right. We'll have of an arithmetic shift case numbers, which is upward or downward. So whereas in the case of an zero fills, with a sign extension, we'll have a normalization or denormalization for an block floating point over here. Okay. Similarly, we are in need to know what are all the different buses of TMS 320 C54X processor, and we have to list the functions. So actually, we'll have a 8 to 16, where there is 4 program bus for an data buses and a 4 address bus we'll have over here. So whereas the case in program bus, what it is, it carries the instruction code and immediate operands from program memory. Whereas in the case of some data buses, actually the CB and DB which carries the operations that are read from data memory, whereas EB which carries the data to be written to the memory. Whereas in the case of an address buses, we'll have often carry the addresses needed for the instructions executions over on it. Okay. So what about the case of functions of program controller of ASP software? Actually, it decodes the instructions, it manages the CPU pipeline, it stores the data status of CPU operations, it decodes the conditional operations over on it. Okay. So this is the thing. What about its memory? The memory will have a traditional microprocess, will have a register to register, limited bandwidth, and then we'll have often memory to memory, higher memory bandwidth, which is up to 6 memory fetches in an instruction cycle. We'll have a parallel memory banks, which have a small, fast, and simple memories. Finally, we'll have around about an internal versus external. We'll have a fun pinpoint communication, speed penalty, and off-chip buzzing, internal buses, or we'll have often multiplexed to the outside, expanded only one memory of off-chip. Okay. So apart from that, we are in need to know what are the advantages of an hardware architecture. So we'll have often there are two separate buses which is available for program and data memory in hardware architecture. So what will happen? So if you're having often two separate buses, so the content of program memory and data memory, so which can be accessed in parallel way. Okay. So what will be requiring over here? So the number of clock cycles required for the memory access will get reduced over. Okay. So that is the main advantages when we are saying about the hardware architecture. And already we said that what about the applications of an PDSP? So we have an application, so image processing, speech recognition systems, digital cell phone, noise cancellation, wireless communication, satellite communication, motor control, and then video conference. So these are all the applications which is designed in the case of an programmable digital signal processor. Okay, so this is about a major thing which has to be seen over in the case of an DSP processors. Okay, so when they are saying about they are to be the special purpose digital signal processors, which is particularly specifically required for DSP processing applications. Okay, but the normal microprocessor which does not have these special features like pipelining, multi-port memory, multiple access memory, modified bus structure, multiplier and multiplier accumulated over on it. Okay, the remaining thing we can see in the next class.